Well, hello. It's great to be at the inaugural SauceCon conference this year. For those of you that don't know me, I'm Shivani Sharma, and I'm a senior engineering manager at Slack. So my first team was the test automation team, and when I joined in 2015, it was a handful of web app engineers and one Android and one iOS automation engineer each. And when we first started, we were lucky that we had some experienced folks on the team, and they had already gotten set up with Sauce Labs, with Selenium, and all these other tooling. So we had a lot of basic stuff there and a handful of tests. And as we went through rapid growth in 2016, where we added many more engineers, all writing code every day and also deploying code 50 times a day, we definitely had to figure out how to scale. So today I'm going to be talking about how Slack approaches releasing code with confidence. And first, though, I'm going to talk about why quality is so important to Slack to begin with. That's me.
So, what is Slack? So Slack is where work happens, and it's a platform where lots of tools that you use, such as Google Docs, Jira, Zendesk, and Dropbox, all can bring the information into one place. And it's powered by our powerful search, and it makes all this information accessible to you. And Slack's mission is to make people's working lives simpler, more pleasant, and more productive. So how does Slack feel when it's down? So we get a lot of interesting tweets from our followers. Here's another one. This is one of my favorites. Are you supposed to talk to people like an animal? And this one. So we get some pretty dramatic followers as well. So how many people use Slack? We have 5 million daily active users, and they're connected to our service for 10 hours every weekday. And 2 of those hours every weekday are actively using our product. That's 10 million hours every day that's spent on Slack. That is a lot of productivity. And that is why quality is so important to Slack. And I kind of did some fun math here. So 10 million hours, that's 4,807 business days. And it takes us back to ancient Greece times. So that's how much time every single day is spent on Slack. And that's where our scale is. And this is where the automated testing team comes to the rescue. And we have a mission ourselves. So our mission is to make sure that our software development process is simpler, more productive, and our product more pleasant to use. And it's important to note that one of our company values is empathy and courtesy. And that's empathy for not only one another, between the automated testing team, with our developers, with our operations folks, but also empathy for our customers, and understanding how it feels to them when their service is down and they aren't able to use the product. So we take every bug, every issue very seriously, and if some of you have written some tickets to our Zendesk, you may have gotten some colorful responses back. So we're definitely playful, and we take it seriously and respond. There's actually a human behind each of those responses. How many of you are familiar with the testing pyramid? Give a show of hands. Awesome. So how many of you have a perfect testing pyramid? I don't know if you're being forthcoming here. You want to share your secret? All right, well, most of us probably have a testing pyramid that looks more like an ice cream cone. And especially at a company like Slack that has not been around too long, we definitely started out that way. And it takes time to build a really good system of automated tests that are built into your continuous integration pipeline. So we start off as an ice cream cone. We strive for the ideal, which is the testing pyramid. And this is a concept coming from Success with Agile by Mark Cohn. And it's important to note why this testing pyramid exists. So this image here doesn't have the manual testing, but obviously a human that's testing the same thing over and over again as code is changing, it's going to be expensive. You've got the salary of the human, and there's also time. And as you get down to the bottom level, which is a unit testing, those tests run faster, and a computer is able to run those repeatedly. So when you're in a continuous integration environment, like Slack, we have over 250 developers in our product engineering. And when they're releasing code 50 times a day, we need a computer to be able to test things quickly, to be able to give feedback to the developers so that they can make quick iterative changes if there's any issues and catch it before we go out to deployment. Because we have empathy for our customers, we don't want anything to go wrong. So this is a picture of what we strive for. I would say we probably have a little bit more manual testing there, but at the top we definitely have our share of manual testing, and we use Ruby UI testing. We use Apply tools as well for visual diff testing. This does a pixel by pixel comparison so that we have that quality even on a pixel level for our images. We use Ruby for our API testing, and we have PHP unit tests and JavaScript unit tests. So the automation team is responsible for those two middle sections there, the UI, visual, and the API tests. Although having empathy, again, for one another, the automation engineers are also starting to dabble into the PHP unit testing. So what I try to encourage my team to do is to take a holistic approach to quality. Collaborate with the manual QA folks. Collaborate with the engineers on your team that are building the features. And figure out with the manual testing team what are repeatable, time-consuming things that they need to test for this feature, and what are important flows that should be in a regression test, that should be tested over and over again because our code is constantly changing. And we don't want it to break once we actually release the feature and flip that feature flag. And on the PHP unit level, developers have a lot of pressure on them as well. They're building features, they're reaching deadlines, they're getting security reviews for any new features that they're putting out. So there's a lot that they also have on their plate. And sometimes it's hard to also have that attention on the quality itself. So while developers at Slack have been great about writing unit tests, it's nice to have a dedicated automation engineer to look at this holistically and also understand that maybe we're covered on the unit side and I don't even need to create that API test because that's just an extra layer and it's redundancy. The automation engineers, when doing the Ruby API testing, they're testing for, does Slack business logic work? And they're also checking, is the back end, the core of our product, working as we intend it to? And is our app environment running? And is it configured properly? And the tools that we use for this is RSpec, and we have an internal Slack API client, which I'll go into in a few minutes. On the UI front, we're checking to see if the customers can use Slack. And for the technologies we use there, we have RSpec, we use Selenium Water WebDriver, and we have Pizza, which is also an internal gem that we've created as well. I'll go into the reasoning behind why we created this tool. And we use Apply tools for the visual testing, which I talked about a little bit earlier with the visual pixel by pixel comparison. What's really cool about Apply tools actually is not only because with a product like Slack, which is a real-time messaging app, when we have different content flowing in our main chat pane, we can just test layouts as well, and kind of ignore that content. So Apply tools has allowed us a lot of flexibility considering the type of product that we have. So this is I guess some of the emojis didn't render, but this is a look at our continuous integration. So as you can see, below the validate, there's a lot that goes into it. So there's linting, there's unit testing, and the stuff in pink and orange is what the automated testing team is responsible for. And although now they're also kind of dabbling in the unit testing as well. So in order to give a reliable yes or no, there's a lot that goes into there. So we have smoke tests, we have regression tests, and we have to make sure that all these pieces are solid. So there's setting up the data, there's stabilizing our test environment, actually running the tests, and validating the results. And after that, triggering the reporting or alerting for failures and cleaning up the environment. So I'm going to go a little bit into the automation tools that I mentioned. So we have a tool called PizzaGem. It's a UI test automation library that helps us to write clean and stable Selenium WebDriver tests in Ruby. And a little bit about the motivation behind PizzaGem. So we have, how many of you have heard of the page object model? Awesome. So we wanted with Slack being a real-time messaging app, there are some nuances with relocating elements and waiting for elements, and we wanted a bare bones framework and around element listeners for before and after click, and having more stability in our tests. The second thing is the Slack API gem. It's a Ruby wrapper around an HTTP client, and it provides easy access to our Slack APIs. So this motivation was behind, because our mobile teams also use our APIs. So this is a way to have reusable code and better maintainability of our code, since we just have one base there. And the web app team can use it, the Android and iOS team can use it. So that was the idea around creating this gem. And then there's our quality dashboard. This is our one-stop shop for answering what is the quality of Slack today, or even right now. We've made it so that it's real-time piping in test results. And anyone, any manager, any developer can take a look and see where we are with the testing. And the motivation for quality dashboard is, well, who doesn't like to have an aggregated report showing all of the tests? We have API tests, we have UI tests, we have visual tests, and I'll show you a screenshot of what that looks like in a minute. But on the back end for this dashboard, we also track metrics, and we store the failures. We also store retries. We're pretty diligent about not covering anything up. So while we may not expose failures to the developers, if it's failed the first time and passed the second time, that's something that the automation team definitely looks into. And we have an instability bash day every month to drill down to see what are the trends on some of these tests and what we can improve in our system, not only in our tests, but even in our environments. And this test trend data is important because we've been able to find things not even just in our product and maybe improving our tests, but also in some of the tools that we're using. We found some inconsistency in the platforms and applications that we use, that we pay for to use. And that's helped us make everything better. So this is what our quality dashboard looks like. We organize it by our product pillars, and we show how many failed tests, how many unstable tests, and the total number of tests. So this is the front page view, and there's a way to drill down into each of the tests if you see any failures there. As you can see on the left side, there's the history of the tests, the test builds. And here, this is a drilled down version of one of the failed tests. We also have a stability rating for each of those tests. So we have a 24-hour, 7-day, I know it's hard to read, and 30-day rating for those tests. And the reason why we have these 3 different windows of how this test is performing is that sometimes you'll have environmental issues. Sometimes Amazon will be down and everything will be failing, like we all had recently happen a few months ago. And for that reason, it's important to know that what maybe be a low rating for 24 hours might not actually reflect an action that you would need to take to fix the test or whether it's a bug. So it's important to have these different frame of references and to think holistically about what's been going on in the environment, what's been going on with the test, and make the right decision that way. And we have real-time alerting in Slack. So in that cycle that I showed, we have a quality bot called QA bot, and this reports just on failures. And we have a triage person, actually the automation engineers, they rotate triage duty every day. And instead of them having to go to the dashboard or having to see whether there's failures, we have those failures come alerted to us in Slack. So you can go about your work and only drop things when you get an alert. And this is what it looks like. And there's also a link right there to go right to it. So some of the tactical things that we do, it's data. It's hard, I know that we all struggle with flaky tests and flaky environments, but it really just takes being diligent and about understanding that, because you cannot improve what you cannot measure. So it's important to know what types of things are happening in your environment, and what types of things are going to help you improve are actions that you take by knowing what that data is. The other thing is getting organized. So in that dashboard, I didn't show in detail, but we also have an area where we can categorize each of those failures. And that includes the different types of error messages that are being delivered, and any notes that the engineer has that's been on triage. So it's important to have that on a granular level as well. And triage duty. So having someone that's accountable to be able to respond to this, so that there's one single point of contact that's going to drop their things and look into things. So the triage duty person is responsible for checking if the environment's running okay, and also to be the air traffic controller if it's a specific product area bug to the automation engineer or the development team that is responsible for that particular area. And that's why we have those product areas as well. So that information is included as well. All right. So key takeaways: having empathy for your team, testing all the things, and measuring your data, and making sure you're organized with all of the environment failures, and thanks. So we have some time for some questions. Any from the audience? Yes. Oh,
Hi.
sorry, Mike.
Excuse me. Early on, you mentioned that you use Ruby API for your, you use Ruby for your API testing.
Sorry.
From where did you arrive at that decision? Was it open source relative to other tools and maybe some other API-specific tools? How did you come up with, you know what, we're doing Ruby?
That's a good question. We have a lot of engineers that were already at the company. Well, actually, our first early automation engineers were pretty experienced. They were pretty advanced with their Ruby skills. Some of them have also worked at other consulting companies. And that was already something we had in place when I joined, and they had kind of vetted the tools. So I may not know all of the details around why we got to that place, but we do have Sergey here in case there's anything else you would want to add. Sorry to put you on the spot.
Hi, I'm Sergey. I'm on automation team at Slack. We came to Ruby, I believe, when I joined, we used, for mobile testing, we used Xamarin, and part of that was the Calabash Ruby stack. When I joined, I was the first engineer on the web automation, and we decided to kind of stick with Ruby as well, so we can collaborate and use that API jam between web app and the mobile.
Thanks.
I'm just curious, do a lot of the same test automation practices that you're using there, I saw web UI and things like that, does that translate over to native applications as well, or is there a different strategy there, or are you able to mirror the same process with that?
Good question. Could you perhaps state it in another way? Could you ask it another way?
Are you testing your native apps with the same automation strategy as you are your web app?
Okay, so between like the Android and iOS
Yes,
apps
exactly,
versus
yeah.
our web app. Okay. Slightly different. So we were using Calabash for our Android and iOS testing. We've recently moved away from that. On the Android side, we have moved towards espresso testing and using emulators. And on the iOS side, we're still figuring out what to do there. We've had some, after the iOS update in October, we've been having issues, I think 10.8 or something like that. I can't remember the version. But we've been having problems with iOS testing since October, and I think probably many of you have. I've talked to some folks here in the audience earlier. So we're revisiting that. Right now, we are still in POC mode with seeing if KIF is going to work for us, also with performance testing there. And we're also looking into expanding XCUI tests. But iOS has been a challenge for us in the last few months, for sure. Android is definitely a lot easier.
Linda, front row.
In one of your charts where you showed the test results, you
Yes.
had 0 failures and a bunch of passes, and then you had a middle category. I forget what you labeled that one as. Yeah, test unstable.
Yes.
So what is test unstable, and how do you distinguish that between
Yes.
failures?
Yes. So the unstable tests are the ones where the test failed on the first try and it passed on the second try. So we only do 2 retries because we try not to cover up the nuances in the environment too much, because we do have a complex system and things are changing all the time. But also, I didn't want to hide it because sometimes there are intermittent failures, and in order to see some patterns, we've actually been able to find some interesting issues with some of the toolings that we're using, specifically for our Slack video calls. So testing that has been interesting. So the test failed is when it's failed twice. Unstable is failed first and then passed on the second try. What we alert on is only the failed twice in a row.
And you keep track of the unstable one?
We keep track of those. Yeah, so every month when we have an instability bash day, the entire team works together and we pull up the numbers of what are the most unstable tests. And that's the rating. We kind of look at the failure rating as well. But we kind of look at these numbers and have an aggregate of like, what are the worst offenders here? And then work based on that and try to chip away at it. And after a year of chipping away at it, we've made a lot of improvements. For instance, our smoke tests, I think that was over here. Our smoke tests for a little while were having it was only I think it was failure of 40% at one point. It was in October. And we went through and diligently categorized all the things that were happening and started to chip away and address them. And we got it down to 3%. So it was a big difference by just taking that time and attention to actually drill down and not just being like, oh, it's an environment thing, it'll be fine tomorrow. There were some flaky things happening in the environment themselves that we helped make more robust, and we worked with our internal toolings team to be able to do some of that work.
Could you elaborate on the stabilize the environment in that same chart that you show?
Yes, so we have a tool that we created to make sure any new tests that are added to our regression suite, that we run it 100 times and before we actually check it into our main test suite. And that's to make sure that there isn't any weirdness going on. And sometimes there can be exceptions, but we won't put it in the regression. Maybe we'll have a separate build that's maybe just reporting to a specific team. The calls team was one of them, so that because there was an issue that kind of went on for a few months and it took some time to solve. But yeah, the testability is actually running it through our stability tool to run it 100 times and see what that pass rate is there before actually merging it into our test suite.
What point do you guys typically integrate like UI or API automated tests during your product development cycle? Is it while a feature is being developed, once it lands in the test environment, after it's been stable in prod for a while? Can you just talk through that a little bit?
Yeah, we do it well, it depends on the team, and it depends on how, when development was completed and when we switched the feature flag, but generally we have those automated tests ready to go before the feature flag is switched in production. And when that happens, there's usually communication with the developer and the automation engineer so that they can also make the switch as well to expect that change.
Hi.
Hi.
So I have 3 questions. First question is, how does your team deal with the context switch between Ruby, PHP, and you said your team may get into JS maybe. Second question, how fast is your release pipeline given that you have a bunch of stages you have to go through? Third question, does your team actually do canarying of your builds, since you mentioned that you guys release really frequently?
Yeah. So first question, can you repeat that, please?
First question, how does your team deal with the context switch between the different languages, primarily Ruby and PHP?
Yeah, so right now the team hasn't quite dabbled into the JS unit test quite yet. I have some folks on my team that are looking into it to see what they can do on the front end, but mostly we've been using visual testing there for the front end, and it's actually the visual tests have actually caught some functional bugs, which has been interesting. So between PHP and Ruby, they're mostly working in Ruby, and it's just when they get to the point where if there's a feature that does have API testing, that's when they're holistically looking at, okay, should this be an API test? Should this be, is there more that we can have on the PHP unit side? Are we covered there? And kind of figuring out what balance of coverage to have there. So it's generally when the feature has new APIs.
Got it.
So it's not too much context switching like multiple times a day by any means. It's maybe over a span of a couple weeks when there's a project being built.
Well, I meant, for the context switch, I meant like, when you're writing the test, there's a tax you pay for the type of talent you have on your team, right? So I was mainly referring to that, but the second question was more around your pipeline. How fast is it? Like if you had to release a build, let's say, in a couple hours, is that pipeline capable of going through all the tests and qualifying your build to release?
Okay, so the smoke tests take about under 5 minutes to run, and the regression tests take 15 to 20 minutes to run, including the API tests, I believe. So yeah, within 30 minutes, you can have an answer on whether you're good.
Awesome. So the last question was canarying.
Yes.
Do you guys have a concept of canarying your builds to a subset of your users and figuring out whether it's good or not, and kind of rolling it back if you find issues and so forth?
So we don't have a canary for our product releases, but we do have a canary for our message server and like our back-end infrastructure that is the service that's keeping Slack up. So when we have infrastructure changes on that end, there's a separate infrastructure team that is more intertwined with our operations folks, and we canary build those types of major structural changes on the back, but not for product engineering.
Okay, cool. Thank you.
I just have one question. You mentioned that you rerun, so when you do the rerun, you only rerun fail test or everything?
Yes, we only rerun the failed test. So we run through everything, we look at what failed, and we only rerun the failed tests.
Thank you.
Hi.
Hi.
So looking at the CI/CD pipeline slide, I saw that after deploying it to stage environment, you only do a sanity.
Yes.
Why not validate?
We want to do the validation as early as possible. So in continuous integration, continuous deploy, and with like agile concepts, once the code is merged into our master branch, we already believe it's too late. So the sanity test is literally just one test, and it's just signing into a team and making sure that we can do that. So there isn't some like weirdness there, but most of the testing is done before that code is merged into master, so that you can have a faster feedback loop to the developers in case that there's something that needs that's
Right.
failing.
I mean, why not validate also when on stage environment? I mean, early testing is definitely good.
Yeah.
Faster feedback, but there can be some surprises when there are multiple teams working, and when they merge it on staging environment.
Right.
It's different from development environment.
Yeah, and yeah, I see your point, and there's definitely companies that have that I've worked at that have done that as well. Right now, with limited resourcing and we're still a pretty young company. We're trying to focus earlier, and then also the fact that we deploy 50 times a day. If there is a problem, generally we'll find out about it very, very quickly, and we have a very quick response and can just deploy in the next deploy, which we can manually do any time. and have a fix for that generally.
Okay, and
Yeah.
it's a trunk-based development that you follow at Slack?
I'm sorry?
Is it a trunk-based development?
What do you mean by trunk-based?
Single source of truth. So you don't have like feature branches separate, it's like one master.
Yeah, we have one master and we put things behind feature flags.
Okay, thank you.
Regarding WebDriver, I was just curious, are you using Selenium in Ruby or are you using something like the Water Gem?
Yes, we're using Selenium Water WebDriver in Ruby.
Thank you. Are you using the cheesy gem as well, or are you using a modification of that?
It's a modification. So our pizza gem is a modification. It's cheesy, but with more what we need to be able to do the real-time test, messaging testing.
Extra cheesy.
Extra cheesy. That's why we called it pizza. All right, I think that wraps it up.